Okay, so when you get into Schoology, you open Unit 8, Project 8 Information and Student Survey Responses. And you're going to see on the top row that's yellow, those are the questions. You'll notice they all start with rate how, so like they all look the same, but if you click on them, you can see that they're the different questions. The one that we need is all the way at the end. I think it's number 28. Yeah, 28 is the last one. All right, so this is not a question you asked. This is the question that I asked. Students should be allowed to leave school after middle school. And then below it, we have all the answers.
You're going to count it. You'll see what's supposed to
Yeah, we're going to count right now. So what I need you to do now is, first, I need you to try to look at this chart and figure out how many people answered the survey and ask your group, see if they agree with you. Okay, Nate, that's got to stay away. Did you guys find this in Schoology? We're looking at student responses. So go into the Project 8 and then the Project 8 information, and then student survey responses.
Did you have to type all these stuff?
No, Google Forms makes this for me.
So automatically, they just give the data and just organize it for you.
Yeah,
That's pretty cool.
yeah. There's a lot there. I agree. What we're doing is going all the way to the right to number 28, question number 28. And the first thing I want you to do is go into 8 and Project 8 information and then student survey. I need you to try to figure out how many people answered the survey. And talk to your group and see if they agree with you. So there were 28 questions on the survey. That has nothing to do with how many people answered the survey. These are all the different answers. That would tell you how many people answered it. What's that?
I don't know how many people answered.
Yeah, so see if see if Jeff gets the same.
I'm wait till you get your answer.
So where is it? I have to find it.
You're going to go all the way to the right.
Okay, so let's
So you
find
just
it.
scroll over to the right. And then we're looking at column 28. And we're trying to figure out how many
Student
people
survey.
answered it.
Student. Oh, I found it. I'm on it.
Yeah.
Student responses.
All right. So if I go down to the last line, I think the last line is number 56, but it's not exactly 56 people who answered it. Why is that? Some people, well, they still answered it, even if they put neutral. Does every line represent an answer? What do I have to leave out? The question, right? So it would have been 56 people who answered it, but I have to leave out the question. So how many students answered the survey? 55. Good. All right. So on your paper, the first thing we're going to write is 55 students answered it. Yeah. Okay. 55 students answered the survey. Now, this is where you're going to do a little bit of counting. If you're good with sheets and you know how to sort them, you won't be able to sort that one because you don't have edit capabilities, but you could copy it and try to sort it. Or you can just count, okay? So going back, you need to count how many people said 1 strongly disagree, then how many people said 2 disagree. If you would like to work with the people at your group, you can split the task up, say like I'll count the 1s, you count the 2s. And if you don't have anybody in your group, you can feel free to move yourself if you want to do that, or you can just count them all yourself. That's up to you. So I need you to count how many people said each one, and then we're going to put that on your paper. How many people said 1? How many people said 2?
You organize it by column.
Yeah.
I really just kind of, I was making sure.
All right.
I counted 1. I only did 1.
We are going to make sure we have the right numbers because we have to continue making sure we get the right things. So for number 1, PJ, how many 1s did you count?
1,
33. Anybody else count 33 1s?
I did.
Good. That's what I got to.
Why you want
All right, I feel pretty good about 33 ones there. And then after that, it wasn't as hard to count. How many 2s did you get? 7. How many 3s? How many 4s? And how many 1s? Good. All right, so make sure that you're actually trying to do these things along with us, because that's what's going to help you when you're doing your own project. So here says list all of the responses separated by a comma with no spaces. And the reason why we have to write that list out is because when you find the mean and the standard deviation in Desmos, you can't put these numbers in. These numbers aren't going to tell you anything. What you do have to put into Desmos is a list that has 33 1s, 7 2s, 11 3s, 3 4s, and 1 5. Okay, now I'm actually not going to write the commas on the paper because I can't copy and paste it, but when you do your project, list it with the commas, because then you can copy and paste it into Desmos. Okay, and then you won't have to type it twice. So I'm going to write 33 1s. I think I'm going to group them in 10s. 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8 9 10. Then 1 2 3. So 33 1s, 7 2s, 11 3s. 1 2 3, 1 2 3, 1 2 3. That's 10. Here's one more 3. 11 3s, 3 4s, and 1 5. Okay, and writing the list out is going to help you when you use Desmos. Remember what numbers you're actually putting into Desmos. So if you have it written out, you can find the mean by typing the word mean, parentheses, and we're going to type out this list. There are some shortcuts. For example, I'm going to type 10 1s, and then I'm going to copy it and paste it a couple times. 1, 1, 4.
How many 3s are there?
11 3s.
How about 2s?
7 2s. Look, I'm getting it from here, Jeff. You see? All right, so I got 10 1s so far. 1 2 3 4 5 6. Then I'm going to copy them and paste them twice. That'll get me 30. I've got 31s, 31, 32, 33. And then I need 7 2s. And then I need 11 3s. And 3 4s. All right, and then after you do the 5, don't put an extra comma, and you'll see your answer for the mean, and then you'll be able to copy that list and use it for standard deviation as well. So I'm going to come around and make sure everybody has a good start on that. All right, so after we calculate the mean, we're going to find the standard deviation just by changing the word mean. Okay. Your calculation should show 1.07, which we're going to round to 1.1. Okay, now that's your mean and standard deviation. We are going to use that here on your normal curve, but I did want to show you that there is a part of the project where you make a histogram chart. We're going to make that in Google Sheets, and I'm going to show you that next class, but I just wanted to show you that so you don't wonder what happened with that when you're looking at a sample project. So here, we're on the back. What number do we put on the middle line? Right here. Yes. So you need to put your mean on the middle line. That's 1.8. And then you're going to add the standard deviation to get to the next one, and you'll subtract on the other side. So take a moment and label your normal curve. Okay, Matthew, what'd you get for the next one? Matthew? Remember, we're adding a standard deviation each time, so we added 1.1 to 1.8 to get 2.9. What's the next one? Good. Beautiful. Jeff, did you do the other side?
Not yet.
Go ahead.
I got 0.7.
Mm-hmm.
Negative 0.4.
Mm-hmm.
And negative 1.5.
Beautiful. Okay, so we have our normal curve labeled. And now it says that we're going to need to use a z-score table. But before we use a z-score table, we actually have to find a z-score. So in this case, we're trying to find the z-score for students who chose 3. So that is going to be our x number. Okay? So I want you to remember z-score formula is x minus mean, one sec, over standard deviation. All right, so I saw you guys putting 3 for the x, 1.8 for the mean, and 1.1 for the standard deviation. And some of you rounded it to 1 decimal place. I get that for the consistency. The reason I'm going to round it to 2 decimal places this time is just because the z-score table gives me 2 decimal places. And so I'm going to do that. The z-score I wrote as 1.09. And then you need to open a z-score table and find the percentile for 1.09. So I'm going to open a z-score table. You can search for one, or you can use that ztable.net one. So the reason I rounded it, Jeff, is because the z-score table has 2 decimal places on it, so I thought that would be a little bit better. We're not... So you can either Google a z-score table, or you could use this one. It's z-table.com. Has ads. All right, so I should not be on the negative side. I have to scroll past the negative side to the positive side. And then on the positive side, I need to look at 1.0 and 0.09, and that's my number there. Okay, so we got this one 0.8621, and we said that 0.8621 is going to give us 86.21%. Now, 86.21% chose less than 3. To find what percent chose more than 3, we have to subtract it from 100%. So go ahead and find that. All right, I'm getting 13.79%. Did anybody else get that? Yeah, okay. So what this is saying is, by using a normal distribution to analyze it, we have 86.21% disagreed. They chose less than 3. And 13.79% agreed. They chose more than 3. One sec. But we're going to compare that to the actual results. I can find what percent of students actually agreed or strongly agreed, because I'm going to add up the people that said 4 and 5. That's 4 people. And divide it by 55. So you're going to do that now. You're going to do 4 over 55 to find out how many people agreed or strongly agreed. And we're going to see if that percent is pretty close or not. So when I divided, I got 0.073, which was about 7.3%. 7.3%. All right. So what do you guys think? Is that pretty close to 13? I was a little iffy on this. It's not terribly far. However, it is almost twice as much as 7.3%, right? Like 7.3% times 2 would be 14.6%. We're almost twice as big. And I also already knew that the data were not normally distributed just by looking at them, because it doesn't have a peak in the middle and then going down on each side. It has a peak here and then another peak here. It didn't look normally distributed to me. So Because I knew already it wasn't normally distributed, and I didn't feel these numbers were that close together, I said that they're not close. And that means that they're not normally distributed.